So, you ever wonder what it actually takes to bring an AI system into the real world? Because I can tell you it's a whole lot more than just a smart algorithm. Today, we're going to pull back the curtain and really demystify the entire journey, from an idea all the way to a full blown AI product. All right, let's get into it. And I think this is the perfect place to start. At the end of the day, all this complex tech we talk about, it's built by people and it's for people. This quote really sets the stage for everything we're about to cover. We're not just discussing code, we're talking about systems that have a very real impact on our lives. So, here's the game plan for today. We'll start by looking past the algorithm itself. Then we'll get our hands dirty with the true foundation of it all, data. From there, we'll cover what it takes to actually launch a model. Then, and this is crucial, how to keep it running smoothly. And finally, we'll talk about the team that makes it all happen. All right, first up, let's tackle the biggest myth in AI. This idea that it's all about the model. The reality is there are two completely different worlds when it comes to machine learning. And this is where you see the huge difference. On one side, you've got the research world. Think clean, perfect, static data sets. The only thing that matters is getting the best possible score on your model. But then, you step into the real world, into production. Suddenly, the data is messy, it's alive, it's always changing. And your focus, it flips completely. Now it's all about reliability, making sure the system doesn't crash, making sure it can scale. And yeah, you've got a ton of new people, from business to DevOps, who all need something from you. It is a totally different universe. I love this analogy because it just makes so much sense. Think of your AI as a fancy restaurant. Sure, the algorithm is your star chef who gets all the press. But what happens if the ingredients, your data, are bad? Or if the kitchen, your infrastructure, is falling apart? Or if the waitstaff, your operations team, can't handle the dinner rush? The whole place fails. That chef, no matter how brilliant, can't do it alone. That restaurant analogy brings us perfectly to our next point, which is all about those ingredients. We're talking about data, the absolute foundation of any AI system. And believe me, it is the most critical and often the most expensive part of the whole puzzle. This quote right here from Richard Sutton really nails a massive shift in how we think about AI. For years, there was this big debate. What's better, a genius algorithm, the mind, or just a ton of data and computing power? Well, the last decade or so has given us a clear winner. Turns out, having more good data usually beats having a slightly fancier model. Data is absolutely king. So, how do we get that data ready? It all comes down to a process we call ETL. First, you extract the raw data from everywhere. Logs, user clicks, you name it. Then comes the really hard part. You transform it. You clean it, you give it structure, you make it useful. And finally, you load that beautiful, clean data into a system where your models can actually use it. This pipeline is literally the lifeblood of your AI. So where do you put all this stuff? Well, you got two main choices. A data lake is just what it sounds like, a giant pool of all your raw, messy, unstructured data. It's awesome for just exploring and experimenting. A data warehouse, on the other hand, is super organized. It's for your clean, processed data. It's a bit more rigid, but it's perfect for running business reports and analytics. In most big projects, you're going to need both. And here's why all of this matters so much. Getting good, clean, labeled data is incredibly hard and super expensive. Just picture this. You're trying to train a model to spot diseases in X-rays. You can't just ask anyone to label them. You need actual radiologists, and their time costs a fortune. This data labeling step is, more often than not, the single biggest bottleneck and the biggest cost in an entire AI project. Okay, so our ingredients are prepped and ready to go. Now it's time to bring our chef into the kitchen. This section is all about the nitty-gritty of taking that model you've trained and actually getting it out there to serve live predictions to real users. But first, let's clear up a few things. People have some crazy ideas about deploying models. They think you just launch one model and you're done. Nope. They think its performance will just stay perfect forever. Not a chance. They think updates are like a once-a-year thing. Far from it. And my favorite, that worrying about scale is somebody else's job. Let me tell you, it's everyone's job. The reality of production is constant change. So how do you get those predictions to your users? Broadly speaking, you have two flavors. Batch prediction is where you do all the calculations ahead of time, maybe every few hours. Think about your daily movie recommendations. It's super efficient, but it's not instant. Then you have online prediction. This is for right now decisions, like checking if a credit card swipe is fraudulent. You need lightning fast responses. but that means a much more complex and expensive setup. And to make those real-time systems work, you have to know about this concept, stateless architecture. All it means is that the server handles your request and then completely forgets about you. Why is that so important? Because it means your next request can go to any available server. That makes it incredibly easy to just add more servers, what we call scaling horizontally, to handle huge spikes in traffic without breaking a sweat. And you might think, okay, this is just tech stuff, right? Wrong. These choices hit the bottom line hard. We're talking about fractions of a second. Just look at this example from Booking.com. They found that a tiny 30% increase in latency, and we're talking about milliseconds here, cost them 0.5% in conversion rates. Now, for a company that size, that's an absolutely massive amount of money just vanishing into thin air because of a little bit of slowness. Okay, so our model is live, we're making predictions, so we're done, right? Not even close. Now the real work begins. Welcome to the world of MLOps, keeping this whole system healthy, reliable, and always getting better. One of the biggest enemies you'll face in production is something called data drift, or data distribution shift. It's simple, really. The world changes. Customer behavior changes. So the data your model is seeing today is not the same data it was trained on 6 months ago. This is the silent killer of AI models. It just causes their accuracy to slowly rot over time if you're not watching. So how do you fight back? You monitor everything. You watch the incoming data to spot that drift we just talked about. You watch the model's outputs to see if they start looking weird. You watch all the basic system health stuff, latency, errors, the works. And most importantly, you have ways to track its real-world accuracy to make sure it's still actually doing its job. And that leads to this really cool and safe way to update your models. The model that's currently live in production, that's your champion. Meanwhile, in the background, you train a new challenger on all the latest data. You test it like crazy, and only if it proves without a doubt that it's better than the current champ does it get to take its place. This constant cycle is how you keep your AI system at the top of its game. And if you ever need a reminder of why all this monitoring and reliability is so important, just look at this number. A single hour of downtime for Amazon on Prime Day could cost them up to $100 million. 1 hour. That number alone tells you everything you need to know about why system reliability is not a nice-to-have. All right, for our last section, let's pull the camera back. We've talked about data, models, and infrastructure. But now, let's talk about the single most important part of any of these systems, the people. Because make no mistake, building a production AI system is a team sport. It absolutely takes a village. You've got your ML engineers writing the code, data scientists figuring out the right problems to solve, and your infrastructure folks keeping the lights on. But you also need subject matter experts who actually understand the business and leaders who can define what success even looks like. Nobody can do this alone. And that sense of teamwork has to extend to a shared sense of responsibility. We have to build these systems to be fair, to be transparent, and a really practical tool for doing that is something called a model card. You can think of it like a nutrition label for an AI model. It just clearly states what the model is supposed to be used for, what its weaknesses are, and how it was tested. It's a simple way to make sure everyone is on the same page about using it ethically. So I'll leave you with this one question, because I think it sums up everything we've talked about today. The goal isn't just to build a cool model that gets a high score one time. The real challenge and the real prize is in building a complete, sustainable system that can deliver value day after day without falling apart. That's the difference between a classroom project and a real-world product.